Okay, as you can see, items or tasks number 15 until 19 should be submitted today by noon. Okay, using the link. I actually set up multiple Google Forms. So when you submit, please make sure that you submit to the correct link. Yeah. Like for example, I received one submission for to this form. To this form, the form set up for 14 April. I received one submission, and I actually don't know whether it's for today's one or for next week. So please make sure that you submit using the correct link. I let all the forms open for submission because I'm not sure whether if some of you can do very fast and can submit for next or next, right? So I let them open. But for overdue submission, I try to leave it open also. So because once you submit, I have the timestamp. I know when you submit, what the date, what date of submission, time of submission I also have. So means that although someone submit late, they still can claim the marks for the items they achieved. Okay, perhaps they will lose the marks only for submission on time. All right, so even though after the due date, whenever you feel okay, you can submit also previous items. Okay. All right, so if you don't have any question, I will browse through a bit the chapter 2 slide. I hope you watched the video already, but this will be just a little bit of refresh. Chapter 2 is about shear of open and closed thin wall beams. Here we need the two keywords here are shear flow and shear center. Shear flow is a quantity we use to analyze the distribution of shear. Because if we have a beam, if we have a beam like at the left or at the right, and we apply it for shear force. For example, this is a spar of a wing. There is a lift, so the lift will somehow create a shear force. Let's say at the wing root or any position of the wing, there will be shear force. Okay, you need to recall to the structure 1 and also strength of material. Strength of material when you draw the shear force diagram and bending moment diagram, right? When you need to analyze the shear force, suppose you cut the beam into two halves, then you integrate the shear force distribution or lift force distribution above the beam, then you can get the shear force at where you cut the beam, right? So that will create a shear force no matter how the shape of the beam looks like or how the wing or how the fuselage look like. There will be a shear force distribution. However, to show the shear force distribution in an easier to understand manner, we use the shear flow. Okay? Because when we apply a shear force to the beam, for example, if we apply a horizontal shear force to this any of the beam, okay, then the shear will somehow apply along the length of the beam. I mean cross-sectional length. It will follow the direction as shown is S1 arrow, S2 arrow, S3 arrow. The shear force, when you apply to a beam, internally to the cross-section, the shear force will flow along the wall length of the beam. The value will change continuously. Of course, show you a diagram.